Okay, everybody, this is Mr. Combs. Let's talk a little bit about slope. If you read on your information sheet, you'll see that there are three ways that we can find slope. And once again, I couldn't really find a video that I liked online that talked about finding the slope using the graph or when given the graph. So I thought I'd create one. So if you read the information sheet for this week, you'll notice that it says that in order to find the slope of a line when given the graph, what you need to do is locate 2 points on the graph. So I've done that for us already. I have 2 points on this graph located, and what we're going to do is we're going to count the number of spaces that we have to move over and up to get from one point to another. Okay? If we remember that slope m, and we always let m represent the slope, slope is rise over run. That's one way to think about it. And rise basically is how far a line, or how much a line goes up and down, and the run is how much a line leans over. Okay? Alright, so what we need to do is we need to count the number of units that it takes for me to get from this point to this point. And I think that the easiest way to do that is to draw a triangle. So I'm going to, in red here, draw a triangle connecting these 2 points. So I'm going to start my triangle from this point, and I'm going to come down here. And so I've created a triangle. It's a right triangle. And basically what I'm going to do is I'm just going to count the number of units in this leg, count the number of units in this leg, in this one, and the number of units in the leg that's parallel to the horizontal axis will give me the run, and the number of units that's parallel to the vertical axis, or the y-axis, will give me the rise. So I'm just going to count, okay? So I'm going to start here, and I'm going to count spaces. So if I want to get from here to here, I need to go 1, 2, 3, 4, 5, 6, 7 spaces. So I'm going to say that in this case, the run is 7. Okay, if I count the rise, I'm going to have to go 1, 2, 3, 4, 5, 6, 7. That's also 7 spaces. Alright. Now you always want to apply, when you have a diagonal line, a positive or a negative to your slope. Okay? So a positive slope, or any line, let me say any line that has, or that goes up to the right. So if a line slants up to the right, then it's going to have a positive slope. Okay? So in this case, this line slants up to the right, so it does have a positive slope. So I'm going to say that this is a positive 7 over 7. The only thing left for me to do now is to reduce. So 7 over 7 reduces to 1. So I can say that this slope is positive 1. If you can reduce this fraction, you want to. But if you can't, then that's okay. Alright. Let's look at another line and see if we can determine the slope when given another graph. Okay, here we have this line. Again, I'm just going to draw my triangle connecting the 2 points, And you can draw this triangle above or below the line. It doesn't matter. You'll get the same slope. So if I remember that slope is rise over run. Let's see, I'll count the rise first. So let me see, 1, 2, 3, 4, 5, 6, 7, 8. So the rise is 8 units. So in this case, m is going to equal 8 over something. All right, let's count the run. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that one's 11 units. Okay. Well, I already wrote 11 there. So anyway, I guess I gave it away. Sometimes I do that. I'm sorry. But yeah, that's 11 units in the run. So 8 over 11 is the slope of this line. Let's apply a sign now. When a line goes up to the right, it's a positive slope. If a line goes down to the right, it's a negative slope. So any line that goes down to the right has a negative slope. Okay? So I'm going to say this is a negative 8/11. So this is a negative 8/11. All right? So basically I can't reduce 8/11, so I'm going to say that the slope here is a negative 8/11. And you can put that negative with the 8, with the 11, or out front like I did in the boxed answer there. So either way, that's fine. All right, let's take a look at another line. Okay, this line is a horizontal line. Okay? So let's take a look at what the rise and the run might be. So if I'm looking at the run in this case, this line has a lot of run. All it does is run. It never actually rises. So you see that it always goes from side to side. It never goes up. So it never goes up. Okay? So it always goes from side to side. So let's use the technical math term lots. It has lots of rise. I'm sorry, run. Now we could choose 2 points and actually count the run between the 2 points, but it doesn't matter what any 2 points that you choose. So we'll just say lots. All right, now let's see how much rise this has. We've already said it has no rise, so if it has 0 rise, anytime we have a fraction where it's 0 divided by a number other than 0, we always say that's equal to 0, right? So 0 divided by 5 is 0, 0 divided by 8 is 0, and so on. So that's 0. So we're going to say the slope of this horizontal line is 0. And in fact, every horizontal line will have a slope of 0. Every horizontal line will have a slope of 0. Okay, so it doesn't matter what horizontal line you see. If you see one that runs from side to side, then you know it's 0. What about a vertical line? Okay, here we have a vertical line. Let's look at rise over run again. In this case, all this line does is rise, right? It never runs. It never goes from side to side. It always just goes up and down. So it never runs. All it does is rise. So let's say our slope is lots of rise over no run. Now, what do we say when we have 0 in the denominator or when we have division by 0? It's undefined, right? So this slope is undefined. So the slope of this line, we would say, instead of a number, we would say it's the word undefined. And in fact, just like every horizontal line has 0 slope, every vertical line has an undefined slope. Okay, I hope this helps you as you look at some graphs in the homework to determine the slope. And until next time, I will see you later.